Now we connect the three elementary signals through calculus. Starting with the ramp r of t, its derivative is the unit step, dr of t dt equals u of t. The ramp rises linearly, so its slope is 1 for positive time and 0 for negative time, which is the step. Taking one more derivative, du of t dt equals delta of t. The step has a sudden jump at the origin, and the derivative of a jump is an impulse. Combining both, delta of t equals d squared r of t dt squared. The impulse is the second derivative of the ramp. Now in reverse, starting with delta of t and integrating, the integral of delta of tau d tau from negative infinity to t gives u of t. The impulse has zero area until we cross t equals 0, then the accumulated area becomes 1. Integrating once more, the integral of u of tau d tau from negative infinity to t gives r of t. We accumulate the constant 1, producing a linearly increasing function. So, delta integrates to step, step integrates to ramp, and in reverse, ramp differentiates to step, step differentiates to delta. In discrete time, differences replace derivatives and sums replace integrals. The first backward difference of the unit step gives the Kronecker delta. Delta of n equals u of n minus u of n minus 1. At n equals 0, u of 0 minus u of negative 1 equals 1 minus 0 equals 1. At all other n, the values cancel. For the ramp, r of n equals the cumulative sum of u of k, giving 0, 1, 2, 3. The first difference of r of n gives back u of n. Let us verify visually. Draw u of n as a stem plot, zeros for negative n, ones from n equals 0 onward. Now draw u of n minus 1, ones start at n equals 1. Subtracting, at n equals 0, 1 minus 0 equals 1. At n equals 1 onward, 1 minus 1 equals 0. The result is delta of n, a single stem at n equals 0 with value 1. This is the discrete time equivalent of delta of t equals du of t dt. Let us organize into a comparison table. Unit step. Ct has u of t line plot. dt has u of n stem plot. Impulse. Ct delta of t is the arrow with unit area. dt delta of n is value 1 at origin. Ramp. Ct r of t equals tu of t line. dt r of n equals nu of n stems. The derivative chain in Ct becomes a difference chain in dt, and integration becomes summation. Here are all 6 elementary signals together, Ct and dt versions of step, impulse, and ramp. Continuous time signals use curves and lines. Discrete time signals use isolated stems. The impulse is unique, infinite in Ct, finite in dt. These 6 functions are the building blocks for all of signal processing. This concludes Lecture 3. We defined the unit step for switching, the ramp for linear growth, and the impulse with its shifting, multiplication, and scaling properties. We connected them through derivatives and integrals. Ramp to step to impulse, and integration reverses the chain. These relationships will be essential for system responses and convolution in upcoming lectures.